center for inviting me. I thought what I do as a climate scientist, I'm here really mostly to learn from all of you, because I think we're at the point where the climate scientists have spoken and now we need to get to doing things. But I thought I would give you just an overview on three elements. I would like to talk to you a little bit about really the physics of climate change in Africa, from what I studied, and then talk a little bit about innovation, if you wish, or just perhaps help set the context to discuss the two policy elements around climate change response, adaptation and mitigation. Okay, so the climate science part of it. Africa actually provides a really important example. Yeah, it's just one slide. So. of what climate change means and what climate change means in the present, not in the future. So this on the slide that I will get to in a moment is really an example of a climatic change, a human-induced change that has already occurred. So climate change is here, there's no question about it. Okay, so it's not just about temperature rising, polar ice caps melting, it's also about rainfall changing. Okay, so just to give you a pill of the kind of science that we do as climate scientists, we use models to understand how the system evolved. And here, the target is the Sahel region of Africa. We know that there has been dramatic change, if you wish, in the past. You see it in the red line on the slide here. You can see specifically the shift from mid-century abundant rains to then end-of-century deficient rains. The droughts in the Sahel in the 70s and 80s. So how do we go about understanding and attributing, we say, in climate speak, this to human emissions? We did it in two steps over the course of 15 years. The first step was, so the red line is what actually happened in the real world. The blue line is if you use a climate model and the only information about the real world you feed it is the surface temperatures of the oceans, you see that you can reproduce that drop. You can reproduce the high stand in the 50s and 60s and then the decline into drought in the 70s and 80s. So the oceans have a big part in this climatic shift. Now you go a step further in the green line, and what you do now is you have ocean and atmosphere together in a model, and you force ocean and atmosphere with emissions, greenhouse gases, aerosols, volcanoes also if you wish, and you get the same thing. You get the change in the sea surface temperature and the drought in the Sahel. Okay, so that's how we know that we are, as humans, we've already changed the climate system, in case there was a need for further proof. Now, this does not mean to say, as you say, that it's catastrophe for Africa necessarily, because as you can see at the end, there's actually an upswing. So we are onto a recovery phase of rains in the Sahel. So there's still science to be done to understand what the future could bring, which doesn't necessarily mean that there's an equation there between warming and drying, between warming and drought. Okay, so that's the climate science side. And now, talking about and this is really what I do. And actually, a little bit more of what I do also is then specifically, using models. One thing that can be done that relates to then adaptation is use models to predict the future, not just 100 years from now, but also next season. So I guess the example I want to bring to you as an innovation, if you wish, in the adaptation to climate change arena is the example of seasonal prediction. So using seasonal prediction to, ahead of the rainy season in the Sahel or in other parts of Africa, get a sense for what the season could be like. Will it be abundant or deficient rains? With a percent probability, and then there's still quite a bit of the social science side, social science work to be done to understand, really translate this into then actionable information and understand who is in a position to actually change their practice, say in agriculture, water resources, or to take advantage of this imprecise or uncertain knowledge. So, yeah, that's one example, I guess, and I guess it speaks to maybe innovation or businesses specifically in agriculture, whether they be cash crops or smallholder farmers. Can we take advantage of this? The final point I want to make relates to mitigation, and it's really beyond Well, I have a general understanding of it as a climate scientist. It's not really what I've been working on in terms of research. But here is the question. About a year ago, the report from IPCC came out that talked about global warming of 1.5 degrees and the fact that we really have a very short time span to do something if we want to stave off the irreversible consequences of climate change. And so this is my own way of putting 2 and 2 together, perhaps to just, give some context to what we will be discussing later on. And that is, okay, I showed you that we're already affecting the climate. And even in the Sahel, it doesn't need to be catastrophic drought in the future because the world is warming, we could be facing a more variable climate, a more extreme climate. And so if we want to stave that off, we know that we need to mitigate. We need to reduce emissions and concentrations of greenhouse gases in the atmosphere. And the way to do it is transitioning to renewable energy. So why not put 2 and 2 together? Africa needs energy. I realize it's simplistic, right? But I'm just putting 2 and 2 together. Africa needs energy to develop. It doesn't have much of an infrastructure based on fossil fuels, so to speak. In general terms, of course, Africa is not one sole entity. And so why not really push, as I think the center has been doing, towards renewable energy and this energy transition to really develop Africa. So that's what I wanted to get to. Thank you, and I look forward to the discussion and to learning.
Thank you, Alessandra. Yes, clearly, we have many people this week that understand the impacts of climate change globally, but to hone in on Africa and look at the impacts on Africa, on African agriculture, and we know that vulnerable populations incur greater risk because of their vulnerability. So that highlights the importance of engagement on climate, both mitigation and adaptation in Africa. Next, I'd like to introduce Pat Sapinsley. Pat is the Executive Director of ACRE, Urban Future Lab, and PowerBridge at NYU. ACRE, the New York City Accelerator for a Clean and Resilient Economy, has supported clean tech entrepreneurs since 2009. PowerBridge New York is a NYSERDA-funded clean energy proof of concept center. It's a collaborative effort of Columbia University, Brookhaven National Lab, Stony Brook University, Cornell, NYC Tech, CUNY, and NYU Polytechnic SOE. Pat?
Thank you.